Okay, let's look at the practice exam 2, problem number 9, right? So we want to use the implicit differentiation to find the derivative dy over dx, right? So let's do that. So we have this equation, and we're going to take the derivative with respect to x. So go ahead and take the derivative, right? So first term, since it's a product of two things, so x squared and y, right? Using the product rule, derivative of the first guy, which is 2x, right? Multiply by derivative of y, actually just multiply by second, sorry, right? Then plus first guy is x squared. Then multiply by derivative of the second guy. Derivative of y with respect to x is simply dy over dx, right? Then derivative of negative 3x squared is negative 3 times 2 is negative 6. Then you have x, right? Derivative of negative 4 is 0 since it's a constant. And derivative of 0 is 0 because it's a constant, right? So we have that. All right. Then since we're looking for is dy over dx, this is the guy we want to isolate. So we're going to put all the other terms on the other side first. So here you have negative 6x. We want to put it on the other side, right? So we can do that by adding 6x to both sides, right? Then we're going to put 2xy to the other side by subtracting 2xy. Alright, so let's do that. So what's left on this side is x squared, right? So this guy and the dy over dx. Right, which is equal to, right? So we're going to have 6x minus 2xy. Since 2x is in common, I'm going to go ahead and pull that out. So 2x here, right? So you have, if you pull out 2x from here, you have 3 left. If you pull out the 2x, you're going to have minus y, right? Then you have that, right? Then last step is going to be, I'm going to go ahead and divide through by x squared, right? X squared, right? That looks a little bit weird. I'm going to just change this a little bit. Let's see here. I'm going to, about that, all right? Then if you divide through by x squared, we will be able to isolate dy over dx, which is equal to 2x 3 minus y over x squared, right? There's x on top, so I can cancel one of the x's here. So we can clean up a little bit. So it's 2 times quantity 3 minus y all over x. All right? So that's the derivative dy over dx. All right? For part B, we need to find an equation of the tangent line. So you have a point given. So this is going to be x1, comma y1. So we found a point. And the slope m can be found simply evaluating dy over dx at a given point 2, 4. Right? So we just plug in x equals 2 and y equals 4. Right? So you're going to have 2 times 3, right, minus y. So this is going to be minus 4 over x is 2. right? And 2 and 2 cancel out, so you're going to have 3 minus 4 is -1, right? We found a slope, so we can do a point slope form. So therefore, equation is going to be y minus y1, which is 4, is equal to -1 times quantity, so -1 comes from here, x minus x1, which is 2, right? So this is the equation of the tangent line we're looking for. All right, that's it. I hope that this was clear.